In this video, we're going to talk about some quadrilaterals and triangles, and we're going to create everything and calculate area just using these simple index cards, or you could use a piece of paper, but you'll see how they're connected. So this is a parallelogram. It's also a special type of parallelogram that has 90-degree corners at each angle in the corner, so we can also call that a rectangle. It has a base and a height. Some people call it a length and width, but I want to focus on the wording of base and height. Now I just happen to label the long side as a base and the short side as a height, but it doesn't matter. You could also label this the base, and in that case this here would be the height. And whichever way you label it, the area is the same. It's the base times the height. So let's go ahead and measure that. I happen to have a centimeter ruler here. So it looks like the base is 15 centimeters, so I'll label that right here. And the height is 10. So the area of this is base times the height, and that would tell you how many of 1 centimeter by 1 centimeter square units fit inside of this figure. So 15 centimeters times 10 would be 150 centimeters to the power of 2, or square centimeters. Now I'm going to take the same piece of paper, I have another one right here, and I'm just going to fold it like this. So all I'm doing, I'm going to cut along this line here and just change this shape slightly so that it's still a parallelogram, but it won't be a rectangle anymore. So I've just cut this piece off. I'm going to put over here. So I have the same exact amount of paper. I did not add any paper to this. I did not take any paper away from this. I'm just going to try to keep these together here. And we have a parallelogram. So both of these are parallelogram, and the definition of a parallelogram is that the opposite sides have to be parallel and they have to be the same length. And in this case, they are the same length. And I can measure this slanted side here. Those side lengths are the same here and here, and they're also parallel. Parallel means if you extend those lines forever, they'll never cross each other. Okay, so this parallelogram must be the same area as this rectangle because we didn't add any paper or remove any paper. We just shifted a piece of it from here to there. So it still has a base of 15 centimeters, and we can call this the base. And the distance between these two parallel sides here is how we define the height of a parallelogram. And the height hasn't changed, it's still 10 centimeters. So the area, it turns out, is the same. It's just the base times the height. And in this case, it's still 150 centimeters. Now, in the activity we did yesterday, there is some parallelograms that were drawn like this. This is the same parallelogram. I'm just turning it this way. And it doesn't matter what you call the base. You could call this the base and this the height, like we just discussed on this. And we can do the same with the parallelogram. This can be the base. It doesn't matter. I could call that the base. And these opposite sides are the same. And they're parallel. And then the height in this case would not be this distance here. That's the side length. And I would need that if I was doing perimeter. But no, it's the perpendicular distance, or the shortest distance between these two parallel lines. So if you could extend these two parallel lines, extend them out, it's that shortest distance between these two. So some people can draw the height out here. I could draw the height and say this is the height, this distance here, or inside, doesn't matter. That was one of the other questions we dealt with yesterday. But the height will be this line perpendicular. So do a little right angle here, and that's the height. And that is also, oh, sorry, I don't know what that is. I need to measure it. So let's measure it. So it's going to be different because it's longer this way and shorter this way. So the base, this shorter length here, I'm measuring the new dimensions here. So it looks like it's not super exact, but it looks like approximately almost 12. And this height here is pretty close to 13. So it's not going to be exact because I'm not measuring exactly perpendicular. But if you multiply the exact measurements, it will also get you to approximately 150 centimeters squared. I forgot to put my square units there. Okay, now if we take this shape here and we cut a line right between these opposite corners, which are called vertices or vertex and vertex. Let me draw a line so I know where to cut. So if I cut along this line, I will create two equal sized, equal area triangles. Each one is half of that 150. So any two triangles, if you draw two identical triangles and cut them out, can be formed into a parallelogram. Now let's look closely at this one of these triangles. Let's look at this one here. The base, this distance here, can still be called the base of this triangle. And again, it doesn't matter what you choose as the base. It's just whatever you decide to be the base then tells you how to find the height. But let's say we choose this to be the base, then the height is going to be the distance from this base vertically perpendicular, going straight up perpendicular to the tip of the triangle, to be equal to the height of the tip of the triangle, which is right here. So it turns out that height, that distance, is from here up to here where that tip of the triangle is. So it's still a height of 10 centimeters. So we can show that here. So the height of this triangle is still 10 centimeters. The base is still 15 centimeters. And if we extend this line here, this is perpendicular to the extension of that base line. And we know it's half of the parallelogram. So the formula for a triangle is therefore 1/2 of the base times the height, or some people like to write it like this: base times height divided by 2, and you'll see if you divide straight across you get the same thing. So in this case that would be 150 divided by 2, and what would that be? Yes, 75 square centimeters. Now here's another shape we can make from that starting rectangle. If we take two identical rectangles, and I'm just going to do a fold from this corner here to the top like that, and I'll do a fold, different fold, and that's going to create a trapezoid. So now I'll cut it out. Okay, I've created two identical trapezoids, and what's cool about that is if I turn one upside down and line them up, they create a parallelogram. So we're back to a parallelogram. So two trapezoids make this larger parallelogram. The definition of a trapezoid is that it has two and only two parallel sides. And with trapezoids, we call them both bases. So this has two bases. Since there are two of them, we'll call one base 1 and one base 2. That's called a subscript. And that's just language we use with trapezoids. And it has a height, which is that vertical distance, the shortest distance going perpendicular between those two bases. So that's what a trapezoid is. It only has two parallel sides, and these two are not parallel, and that's how it's defined. So we already know how to find the area of a parallelogram, and we know this is half of that, and that's how we can figure out the area of a trapezoid. So if we measure this shorter base is 5 centimeters. This longer base looks like is 15 approximately, and the height should be the same as our other one, 10 centimeters. So all we need to do is figure out the area of both trapezoids together as a parallelogram and then take half of that. So how would we do that? How long is this large parallelogram base? Well, it would be 15 plus this shorter distance. What's the shorter distance? Oh yeah, it's 5. So the parallelogram has an area of base times height, where this is the entire base. So that would be 15 plus 5, which happens to be these two added together, this long line here, times the height, which is 10. And then we need to divide that whole thing by 2. And that is the area of the parallelogram cut into 2. So now we're doing the trapezoid. So the area of a trapezoid is the sum of the two parallel bases times the height divided by 2. Let's go ahead and finish this off. So this will be 20, doing the parentheses first, times 10 divided by 2. That's 200 divided by 2, which is 100 square centimeters. And that's how you can make a triangle, a parallelogram, trapezoid using just simple rectangular index cards. Now, if you didn't have a tool like this, you could measure a figure using anything that you have around the house, as long as you have multiple of that item. For example, I could use paper clips, and I could measure the base using paper clips. And in that case, my area would be square paperclip lengths. And as long as you maybe provide a picture of that in your project, that would be fine. So I'll do that right now. So it looks like 1, 2, 3, 4, 5 paper clips make up my base of this trapezoid. And the height needs to be perpendicular between the two bases. That shortest distance. It's approximately 4. I could say maybe 4 3/4 to be exact. So I would do, and then I need to know this length. And it looks like that's 2 paper clips. So the area could be, using the formula we just derived, sum of the 2 bases, 5 plus 2, times 1, 2, 3. I'll just go ahead and use 4 for simplicity here. Times our height divided by 2. That would be 7 times 4, which is 28, divided by 2, which would be 14 paper clip lengths. To the power of 2 squared. So lots of creative things you could do. Thanks for watching.